let's say f of x is given as x for x between 0 to 1, and then it's 1 for x between 1, actually strictly bigger, 1 through 3. Okay, let's say you have such a function. And the question is, find the first 3 non-zero terms of the Fourier sine series. Now, we don't actually have to graph this function to know what's going on. All you have to do is just calculate. But just out of curiosity, let's see what this function is doing. This function is like defined from 0 to 3. And from 0 to 1, it's like this. It's a straight function that's y equal to x. And then once it reaches 1, and it flattens out. It's a constant function after that. So you have this function. And you're trying to find the Fourier sine series. Recall that Fourier sine series means that you take the odd extension of this. So it's like as if you're taking a function that's an odd extension so that it's symmetric with respect to this point. Right? If one side goes up, the other side goes down. And you're really trying to find the Fourier series of this odd extension. Another thing I want to say is that if you take an odd extension, if you take a Fourier series of a function, that's like treating this as if it's a periodic function. Right? Fourier series gives you a periodic extension of the original function. So when you draw the final result, the graph of that final result will have the graph that's periodic with one period in this. So it would be like this, and there'll be like a wave with very strange kind of shape. Okay. So that's what we are trying to go for. Okay. But to solve this question, none of these are needed. I just want you to think about what's going on. And the reason I'm just asking for the first 3 non-zero is because the resulting Fourier series is quite complicated, so I'm just asking for the first 3 non-zeros. Okay. All right. So let's think about the formula for this. And I'll just raise this because we don't really need it. Okay. All right. So what's the formula for it? Bn is equal to 1 over L from negative L to L, f of x sine of n pi over L x dx. Okay, so that's the way you find your Bn. But in our case, because f is an odd extension of the given function, and since sine is odd times odd is even, and whenever you have an even function, you can always do this trick 2 over L, integrate from 0 to L, f of x sine n pi over L x dx, and therefore, from now on, if you're ever asked to find a Fourier sine series, this is the formula you want to use. You don't ever have to go back to this one. You can just say, I'm calculating this because I'm just going for the Fourier sine series. Okay. And recall, after you find your Bn's, then the Fourier sine series is expressed as sigma n from 1 through infinity of Bn sine n pi over L x. That's what it is. Okay? All right, let's continue. Bn equals the entire interval is from 0 to 3, right? So what should you take your L as?
Negative 3.
It will be 3, positive 3. Okay, so 2 over 3, 0 to 3. Your function is, okay, I can't state what f of x is because it's different from these two intervals, right? So I can only write it like that. And it's sine of n pi over 3 x dx. That's what we have to do. Now, how do we actually calculate this? What do we do?
Break it up.
Hmm?
Break it up.
We have to break it up from what interval?
0, 1.
0 to 1. And for 0 to 1, what do we use for f? X. From 0 to 1, it's x, right? X sine n pi over 3x dx plus. Then what?
1 to 3.
1 to 3. And what do we use for f? 1. Okay. That's what we need. We have to do these two integrals. All right. And then, let's see, 2/3. Oh, for this one, we actually have to do the tabular again. So let's do the tabular integration here. Plus minus d integral. All right, so you have
Could
x.
you not say that it's just 1/2? Turn x into 1/2 because that's the. Did we do that the other day? Like for that one right there, you found what the area was under the x, like the f of x for the first one. And just set that number, multiply to the sine of that. I thought we did that the other day.
No, the only time you can take some number out is when it's a constant.
All right.
If you have a constant, you can bring it outside the integral. Here, you can't bring the x out because x depends on x. In that case, you're just stuck with this integral. It sucks, but what can you do? You have to do the integral. Sine n pi over 3x. Integrating this is negative 3 over n pi cosine n pi over 3x. Every time you integrate, this will pop up, so the next time you integrate, it will be 9 over n squared pi squared. Still minus with the sine n pi over 3x. Be plus, minus, plus. And then you have to finish with doing this. So let's see what we get. According to this, it's positive x times this. So it's there's a minus here, so it's negative 3 over n pi x, and then cosine n pi over 3x. Then negative times negative is positive. Times 1 doesn't do anything, so you end up with plus 9 over n squared pi squared of sine n pi over 3x. And then to this, what you have to plug in is 1 and 0. Okay. And then plus the integral of this, well, you're just integrating sine. This is just 1. Multiplying 1 doesn't do anything, so you're just integrating the sine, whose integral we actually calculated here. Right? So the antiderivative sine is negative cosine, and when you integrate this, reciprocal of n pi over 3 appears in front. It's 3 over n pi cosine n pi over 3x, and for this we have to plug in 3 and 1. So that's what we have to compute. Now let's plug in 0. Let's plug in 1. If I plug in 1, it will be negative 3 over n pi of cosine of n pi over 3. Cosine n pi over 3. And unfortunately, I don't know what this value is in general. It will be different from 1, 2, or 3, or 4. So that's why writing the general Fourier series is hard. So that's why I was only asking for the first 3. Okay. When I plug in 1 to this, you get 9 over n squared pi squared sine of n pi over 3. And again, I have no idea what that is, so I'll just leave it as that. Sine of n pi over 3. When you plug in 0, because of this 0 here, it'll be 0. When you plug in 0 here, sine of 0 is 0. So when you plug in 0, there's nothing. So that's what you get from the first integral. Now from the second integral, when you plug in 3, well, that I know. When you plug in 3, it's cosine n pi. What's cosine n pi? Yes. Negative 1 to the nth power. Okay. That's cosine n pi. And then when you plug in 1, well, that I don't know. So you have to subtract negative of 3 over n pi of cosine of n pi over 3. And I have no idea what that is. And by the way, minus minus makes it plus. Okay. Oh, but I still see something interesting here. I see this being exactly same as this, but with opposite signs. So can we cancel? Let's cancel. Cancel. And then you end up with, and then if we multiply 2/3, 2/3 of 9 is 3 and 9 cancels with, to leave you with 3. 3 times 2 is 6, so you end up with 6 over n squared pi squared of sine n pi over 3. And then for this one, for the next one, if I multiply -3 to this, 3 and 3 cancels to give you -2 over n pi of -1 to the nth power. So that's your Bn. That's what we calculate for Bn. Nice thing about the Fourier sine series is that because there's no separate another constant term here, there's only one thing. You only need to integrate once. Okay? If you're doing Fourier cosine series, then you have to get a0 and an separately, so you have to do 2 integrals in 2 different integrals. But here, it's you only have to find Bn, and that's it. Okay, so that's your Bn. Now let's actually write down the first 3 non-zero terms. So what is B1? See, this series starts from an n equal to 1, so you have to start with B1. So let's think about B1. B1 is 6 over n squared pi squared. What's sine of pi over 3? Oh, it's 1 here, so I should be replacing n by 1.
Radical 1/3.
Radical 3
3
over 2.
2, yeah.
So that's going to give you 6 over pi squared times radical 3 over 2 minus, that's negative negative, so it's plus 2 over pi. And 6 and 2 can be reduced to give you 3 radical 3 over pi squared plus 2 over pi. That's your B1. All right, and then I guess I need more room here. Let's calculate B2. B2 is 6 over 2 squared is 4, right? 4 pi squared. Sine of 2 pi over 3. Does anyone know what sine of 2 pi over 3 is? What's sine of 2 pi over 3?
Yep. Negative radical 3 over 2. Positive.
Positive radical 3 over 2.
Oh, okay.
Okay? So you get 6 over 4 pi squared times positive radical 3 over 2. They have the same value. Sine of 2 pi over 3 and sine of pi over 3. You have the same value. 2 and 2 cancels. And negative 1 squared is 1, so you have minus 1 over pi. And I guess if you reduce 2 at 6, that's 3, so you have 3 radical 3 over 4 pi squared minus 1 over pi. And then B3. B3 is easy because if you plug in 3, you get sine of pi. What's sine of pi? 0. So this just goes away, and B3 is simply negative 1 to the third is negative 1. Negative 1 times negative is positive, so you have 2 over 3 pi. That's the simplest one. All right, so those are the non-zero coefficients, but it said non-zero terms, so you really have to write this summation down as the answer. So let me erase this part and write down the final answer. So the final answer is this. Okay, answer. You have f of x equal to b1, which is 3 radical 3 over pi squared minus plus 2 over pi times sine of 1 pi over, what's our L? 3, right? So it's pi over 3x. That's B1 times this thing. Plus B2 is 3 radical 3 over 4 pi squared minus 1 over pi sine 2 pi over 3x, because n is 2 and L is 3, plus B3 is 2 over 3 pi, and it's sine of pi x, because if you plug in n equals to 3 and 3 cancels, it leaves you with this, plus many, many more terms. Okay, so you can just start calculating for n equals to 4, 5, 6, 7, and have as much terms as you want. You can just proceed by this, and the graph of that series, if you have many, many terms, it'll be very similar to the graph of this thing. Okay, so that's what a Fourier sine series is.